In this example and in the fourth example, they're a little bit trickier because you can see that we can't just subtract the x coordinates or subtract the y coordinates. We also can't just count the squares or the boxes on the coordinate plane because the points are not vertically right above or below each other, and they're not horizontally left and right from one another. So it's actually not that difficult if you follow the steps that I've given you on your paper. I believe the very first step that I wrote down is that we're going to create a right triangle on this coordinate plane. So this line that's currently connecting the 2 points that we have, and we're trying to find the distance between them, that's going to be the hypotenuse of our right triangle. So we can either create a right triangle above that line, or we can create a right triangle below it. It honestly doesn't matter. No matter what you do, the right triangle is still going to have, excuse me, it's still going to have that space between those 2 points as the hypotenuse. All right, so let's go ahead now and just use the triangle that's below. So what I've done is I have drawn a horizontal line and I've drawn a vertical line, whoops, which is basically the 2 legs of that right triangle. So now what I'm going to do, whoops, sorry guys. So there's the right angle, which means that the horizontal line and the vertical line are the legs of that right triangle. So let's go ahead and just label the horizontal one with an A and the vertical one with a B. So I'm first, all right, so that's step 1. Let me just write this down just to review. Step 1 was to create a right triangle. I'm just going to abbreviate here. Okay, step 2 is we're going to find the horizontal distance. We're going to find the length of this leg. So the 2 ways that I would recommend doing it would be to either count. First of all, make sure that you know what your scale is. I can see that on my x-axis, it's going by ones each time. So once you've done that, you can actually just count the little boxes, 1, 2, 3, 4. You could say the horizontal distance is 4 units. If you don't want to count the boxes, you could pick this point right here, which is at 7, and look at this point here, which is at 3 on the x-axis, and then subtract like we did in that first example. So 7 minus 3 is 4. So that means the horizontal distance, or the horizontal leg, equals 4 units. All right, step 3 is going to be to find the vertical distance, or the length of the leg that is vertical with that right angle. So again, you can either count the boxes, so that would be 1, 2, 3, 4, 5, 6 units. Whoops, I don't know why I did that. So that means the length of that leg is 6 units. I'm going to write that down before I forget. So that's vertical length equals 6 units. Again, if you would rather not count the boxes, you can look at this point here and this point here and look at the y coordinates. The y coordinate is 8 on that point, and down here it's at 7, 2. So you can subtract the y coordinates, 8 minus 2, to get 6. Whoopsie. All right, so we just did steps 1, 2, and 3. The last step is just to use Pythagorean theorem. So I'm just going to put an abbreviation, Pythagorean theorem, which we've been learning in this whole unit. So Pythagorean theorem, remember, is a squared plus b squared equals c squared, where a and b represent the lengths of the legs and c represents the length of the hypotenuse. So we have the lengths of our legs. We have one leg is 4 units. We have our second leg is 6 units, and we're trying to calculate c. So 4 squared, let me extend the page a little bit, is 16. 6 squared is 36, equals c squared. 36 plus 16 is 52. So c squared equals 52. I can already tell that this is not a perfect square, so we're not going to have an integer answer, but let's go ahead and round our answer to the nearest tenth. So I'm going to take the square root of 52 to undo squaring that. So using my calculator, the square root of 52 is approximately 7.2. Again, I'm rounding that to the nearest tenth. So I'm going to say 7.2 units. And we have basically just figured out right now, we figured out the distance between those 2 points. And it's 7.2 units approximately.